In this module, I will discuss superposition theorem. So what is the superposition theorem? So it states here that the total response to a given element in an electric circuit is the uh, algebraic sum of the responses of each individual sources to that particular element if the sources are taken or applied one at a time. So let me explain this uh, statement by giving an example. In this problem, we're being tasked to solve for the current through the 12 ohm resistance, um, where the direction of the current is shown as in going in the downward direction. Now, this circuit has two independent sources. We have the 12-volt source and the 2 ampere source. It can be shown that the current I sub naught is really the total effect of the sources coming from the 12 volts and the 2 amperes. So that is where the superposition theorem comes in. Um, we will attempt to compute for the components of the current that are due to the 12 volts source alone and the 2 ampere current source alone. Now let's say that we want to know the current to the 12 volt or the 12 ohms resistance due only to the 12 volt source. So that means we need to disable the current source so that it won't have an effect to the circuit. So to disable the current source, that means that we need to cut it off from the circuit. So we need to cut this off, either one terminal or two terminals. So that means that what we're really trying to do is eliminate that source from the circuit so that our circuit will now look like this. Now, the current that we will get there through the 12 ohms will now be only due or caused by the 12 volt source. Now, how are we going to compute for the current through the 12 ohms due to the 12 volts? Now that current is not anymore I sub naught, so let's call it I sub naught 1. Let's also assign a current coming out of the 12 volts, so let's call it I sub T1. Um, so I sub naught 1 can easily be solved by first simplifying the circuit. So let's compute for an equivalent resistance for this. So that circuit will look like, so let's say this is our 12 volts. So we will find an equivalent resistance that is a single resistance connected to the 12 volts. So we will or we observe that the 5 and the 12 are in series, so that will give us 17 ohms. That is in parallel with 3, and the overall combination is in series with 6. So that will give us a resistance that is 8.55 ohms. And from there, we can compute for this current, I sub T1. So that current is given by that. Okay. And then Having computed for I sub t1, we can apply current division to solve for I sub 0, 1. So according to the current division, if we have a current that is flowing towards a parallel combination, so this current is I sub t1 flowing to the parallel combinations 3 ohms and 17 ohms, we can use current division. So to do that, we can use this. So I sub 0, 1 is the current entering on the parallel combination times a factor, which is this one. So to compute the current in this branch, the numerator here should be the resistance on the other branch divided by the resistance, the total resistance of the two branches, so 3 plus 17, and that will give us 0.211 amperes. So this is the a component of the current through the 12 ohms due to the 12 volts. We then next determine the effect of the 2 ampere current to the 12 ohms by also disabling the 12 volts source. So disabling the a voltage source means that we need to uh, short out the terminals of the voltage source, or that simply means that we replace the source by a short circuit or a wire. And that will give us a circuit that would look like that. So the current now through the 12 ohms will be the current due only to the 2 amperes. So how are we going to compute for this current? So here it is again, and to know this, how to determine this current, first we need to um, observe if there are parts of the circuit that we can simplify, and we do have some parts that we can combine, and that is the 6 ohms and the 3 ohms. So these two resistances are in parallel and therefore can be combined so that the circuit will now be or will now look like that. And again, here we have a situation where we have two parallel elements. So the combination of 2 and 12, that will give us 14. We combine that, and that combination is in parallel with the 5 ohms. So now current is flowing here. So this is 2 amperes towards the parallel combination. So we can get this current and this current. Now we're interested with this current because this is the current that flows through the 12 ohms. But this current is opposite to the current that we want to solve. So to solve for I sub 0, 2, we can apply current division, but we need to put a negative sign because what we will get is really this, and I sub 0, 2 is in the opposite direction. So we put a negative sign. So 2 here is the current that is flowing through the parallel combination times again a factor. So to compute for this current, the numerator should be the resistance on the other parallel branch divided by the total resistance of the two parallel branches. So 5 plus 14. So that will give us that current, which is the current due to the 2 ampere source. Now we can combine the effects of the two sources. So this is the effect of the voltage source, the current due to the voltage source only, plus the current to the 12 ohms due to the current source only, and that combination will give us this answer. Take note that in getting the contribution for each source, we only consider independent sources. If there are sources that are dependent, we don't disable them uh, to compute for the components caused by the individual independent sources. So that's it for this superposition theorem. On our next video, we will discuss about Thevenin's theorem.